Okay, nanti you have to join back. Kamal Ashraf kena remove, so dia kena join balik. Dia akan jadi macam tu kalau medium record. Okay. Tunggu Kamal jap So, siapa yang ada ni? Ariel, Brian, Carlos, JD, Justin. Kita shortage lagi 3. Brian, where's the rest? Brian, Andrian, and Ariel.
Madam, they're still online. They're trying to online.
Okay, right. Okay, thank you, Brian.
Sure, madam.
I have connection problem. Okay, Justin. Thank you for the response. Mana Kamal tadi ya? Ashraf ya. Siapa yang terkeluar tadi dia kena masuk balik tu. Okay. So, dah record ke belum ni? Okay, we are on recording on air. Okay, now where we are? Okay, the previous one is we already covered on the transient response. Okay, transient response we can divide into two. What's that? First order and second order. Okay, the first order, apa yang kita what's parameter you have to analyze from the first order. You have to know what's the time constant, how to define what rest time. Another one is how to define the settling time. Is it? That one is from the first order of the transient response. Okay, how about the second order of the transient response? Okay, how about the second order from the transient response? What type of parameter you have to evaluate from the second order? Siapa tahu? For the second order, what's the parameter you have to evaluate from the transient response? What's the parameter you have to evaluate? Siapa tahu? Siapa ingat? Cepat! Ni medium buat revision ni. Okay. How about the settling time? The second order. What's the parameter we have to evaluate? Andrian, same here, madam. Lost connection. Okay. Take notes. Okay. Siapa ingat? What's the parameter we're going to discuss for the second order? Mio? Mio ingat tak? Dan ingat tak? Nani ingat tak? Apa parameter yang kita evaluate from the second order? What's the parameter we evaluate from the second order? You have to know the the settling time, the rise time, the overshoot, the maximum peak, okay, and etc. Okay, that's a parameter we're going to evaluate from the second order output response. Okay, now when we already analyze the transient response part, you have to know the error. Okay, you have to know the error. Mana ni? Hilang. Okay, everybody here? Kita ada 15 saja. Okay, tak apa. Okay, we come back to our discussion. Okay, once we finish on the transient response analysis, we want to see error from the output response. Okay, we want to see the error from the output response, right? Okay, from let's say this one, this is parts. We want to analyze the error. Okay, this is consider your input to the system. Okay, and this is your output. Okay, output response from the system. Okay, so we analyze the error. How about the error reflect to our input? Okay, from the slide or from the recorded video, to analyze the error, we have three type of input. Okay, we have what? We have the step, we have the ramp, and we have a parabola. Okay, and then you can see from the table, we have a time function, step in time function, and Laplace transform in time function. Okay, we have three. You have to know this is our three test input we're going to apply as our input in our control system. Okay, from there, right, from there, what you should be able to learn from steady state error is you have to identify the system type. Okay, to identify the system type, you have to represent your system based on this uh, block diagram. Okay, you have to represent your forward gain. What is your forward gain? This is your forward gain. Okay, this is your forward gain. Okay, this is your forward gains, GS. Okay, this is your forward gain. Okay, so you have to represent your forward gain similar to this general equation. Okay, so meaning the denominator. Okay, you have to represent your system based on this like this denominator. You have to factorize. You have to factorize the denominator. You have to factorize in terms of what's a pole P1, what's a pole P2, and a centra. You have to bracket each pole, meaning you have to factorize. Okay, let's say you have this kind of the denominator. Okay, this is you have to factorize. Okay, you have to factorize what is a pole 1, what is a pole 2, and what is a pole 3. Okay, from there, you see s to the power of n. What is the n here? That's the way how to define the system types, right? Okay, so meaning from slide 17, okay, how to define the system type? Okay, it's a value of n in the denominator. But you have to bear in mind, before you define the value of n, you have to factorize your equation from the denominator. Okay, hopefully you can get the information I'm share just now. Okay. Siapa ni salah madam? Line saya tak berapa okey. Okey, noted. Siapa? Hakim ya? Okey. So yang mana line tak berapa okey tu? So actually you boleh tengok pada, that's why madam prepare, that's why I'm prepared the recorded video. So at least you can see or you can go through back. Okay. You can play again and again to get the information, right? Okay. So this is just a summary. What suppose you have to know from the steady state error. Okay, the first one, now you know how to define the system type is based on the denominator. But before you define the system type, you have to factorize the denominator equation. Okay, that's the first one. But once you define the system type, okay, let's say from here we already done how to define the system type, whether We have a three system type. We have to n equal to 0 or n equal to 1 or n equal to 2. We have a three type of system type based on the denominator of the forward transfer function. Okay, once you know the system type, you have you can determine your static error constant. Okay, this is your static error constant. And once you get the static error constant, you can evaluate your error. Okay, and then before that, we have two conditions to evaluate our steady state error. In non-unity feedback, another one is a unity feedback. We have a two condition of closed loop system. Meaning this is our system. Okay, this is our block diagram. Okay, this is of course our input, and then this is our output, and this is our forward gain, and this is the what I'm saying just now. The feedback unity, meaning unity when h equal to 1, or non-unity condition is feedback is not equal to 1. This is they call it is this one. Evaluate steady state error for non-unity feedback system. Okay, that's we have a two condition to evaluate our steady state error. Now the beginning, I will start with the unity feedback, meaning h equal to 1, right? Okay, so where we are, okay, we're talking about system type, okay, 0, 1, or 2. Okay, once you already know your system type, you can refer to our standard table. Okay, this table you can see from the textbook. Okay, this is a standard table. Okay, this table show the relationship between input. We have a three input. This one, this column. Okay, this column for our input, we will dealing with three type of input: step, ramp, and parabola. Okay, and then this is our type 0, type 1, and type 2, meaning s to the power of 0, s to the power of 1, and s to the power of 2. This is your n, right? This is your n. N is represent your system types. Okay, now what is the error constant or steady state error? Okay, so you can see from this table, they want to show the relationship if the system is type 0, okay, if the system is a type 0, you can see this one. Type 0, you can see what is the static error constant and what's the error. Error meaning steady state error, ESS. Okay, this is a ESS, steady state error. Okay, so for type 0, okay, where is the error? Error, you can get the value or you can get the constant value for type 0 when the input is a step. Okay, let's say we have this system. Okay, let's say we have this system. And this is our forward gain. And then this is our output. Okay, when our input is a unit step, meaning 1 over s. Okay, or in terms of time equal to ut. This is a time domain and 1 over s in the s domain, right? Okay, so now we can see for type 0. Type 0, you determine from the denominator of the forward gain. Okay, you determine from here. Okay, what's the denominator for forward gain? Okay, then you find out the n equal to 0. So type 0. Okay, for type 0, you can get the static error constant when the input is a unit step. Okay, from here, you can see here from how the table want to show the relationship between input and system type, error constant, and steady state error. Okay, so for type 0 and the input is step, you can get value of Kp. Okay, once you get value of Kp, you substitute into error equation, meaning Kp. What's the formula or what's equation for Kp? Guys, you can see from my previous recorded video. Okay, this is equation for Kp. Okay, Kp equal to limit. Okay, how to calculate the error? We use final value theorem. Okay, so to calculate the error, we use final value theorem equation. What's the final value equation? ESS equal to limit x goes to 0. Sorry, this one. This is a S. This is a final value theorem. Okay. Oh my god. Okay, S E S. Okay, this is our final value theorem. So we use or we apply how we apply or how we use the final value theorem to calculate the error. Okay, the error, how to get equation for error? Error is we calculate from the previous slide. Okay, I show you the step by step how to calculate the error. I prove from the block diagram. From this block diagram, we calculate the error. Okay, so meaning ESS error equal to our apa ya kita punya error equation. What's our error equation? Sekejap, mana error equation? Okay, this one. Okay, this is our error equation. Okay, and during H equal to unity feedback. Okay, so we substitute into final value theorem. Okay, so we can get this one. Okay, meaning ESS equal to limit S goes to 0 as ES. Okay, this is RS 1 plus GS. Okay, R is our input, depends whether our input is step, ramp or parabola. Okay, actually from the second recorded video, from that's not, I already show to you when we replace or when we apply the value of whether R, whether step, or this is a ramp, or another one is what? A parabola. Okay, parabola is s to the power of 3, right? Okay, we substitute R, uh, whether ramp, or whether the parabola. So we can get the equation for error for each input. Okay, that one you can see from our video, recorded video. Okay, you can go through back. Madam already discussed or madam already show how to our steady state error looks like when we apply input with the step, with the ramp and with the parabola. Okay, so just now where is our table? Okay, from here you can see for type 0. Okay, just now we're talking about type 0. For type 0, only input step will contribute the constant value. Okay, Kp. Kp is a position constant for unit step. Okay, Kv. Kv is a velocity constant for ramp input. Okay, Kv is a velocity constant for ramp input. Ka is an acceleration constant when we apply parabola input. Okay, but if the system is type 0, error will be contribute when we apply input step. Okay, when we apply input step. Okay, so now let's say Kp, you already calculate value of Kp, right? So meaning when you calculate value of Kp, so we can calculate the error. This is a formula error for, this is formula error. You first you calculate your Kp, okay? You calculate your Kp and then from once you get the Kp, you substitute into this equation, okay? You substitute, sorry, ESS, sorry, hold on. How to calculate the error? Okay, so ESS equal to, you substitute into this one. Okay, let's say lah your error is a 0.5. Okay, 1 plus 0.5. So means you can get 1.5. This is your error. Okay, this is for error when we apply step input into our system. Okay. Okay, let's say for type 0 and our input is a ramp. Okay, so when you calculate KV, KV is the formula how to calculate KV is a SGS. Okay, SGS. So you can you from here you can get what's the value of KV? KV is equal to 0. Okay, and when you substitute into the steady state error equation for KV, ESS equal to 1 over KV. If KV equal to 0, of course you can get the infinity error. Okay, same goes to KA. When we apply input parabola into N-type system, okay, maksudnya kalau kita apply input parabola kepada type 0, KA you can get 0. Okay, you can get KA equal to 0 and then you substitute into the steady state error for KA is 1 over KA. 1 over KA, 1 divided to 0, you can get infinity here. Okay, you can get infinity for both condition. Okay, so for type 0, only step input, you can get the error or you can get the value of error. But the rest, you can get infinity. Also, same goes to type 1 and type 2. Okay, for type 1, error or constant when input is a RAM. And the rest, you can get error 0 or you can get error infinity. Okay, same goes to type 2, meaning n equal to 2. Okay, the constant error from the parabola input. Okay, if the Ka equal to constant or you can get value or you can get certain number, right? So meaning from there you calculate your error. Meaning 1 over Ka you can get your error lah, meaning 1 or etc. Okay, is meaning this constant, you can get the number here. Okay, for the error when we apply input parabola. That's the way how to read the relationship between input, system type, error constant, and steady state error. Okay, this is the way how this table summarize or compile the information to show the relationship between four parameter. Okay, ada soalan tak dekat sini? Any question? Actually, apa table 2 ni nak ceritakan dekat you? Ada soalan tak? Guys, any question?
No, madam.
Okay.
No, madam.
Okay, good. Okay, anything I want to share? Ada soalan tak? Any question? Any question? Okay, let's say from this one, exercise number 6. KA equal to 500. Okay, can you determine the type of the system? Siapa boleh teka? If KA, they give a constant number. Okay, you still remember from the previous table, which they only one, whether N, whether type 0, type 1, type 2 will be contribute a constant static, whether KA, KV, or KA, KP, KV, KA, right? Okay, for this exercise, KA is a constant number. Can you determine what is your system types here? If KA constant.
Type 2.
What?
Type 2.
Yes, good. Type 2. Okay. Can we come back our table here? Okay. So they say just now KA is have a number. If you see type 0, KA 0, right? Okay, here. For type 0, KA equal to 0. Okay, for type 1, KA equal to 0. For type 2, KA have a constant number. Okay, of course, the system is a type 2, right? Okay, good. And then the next question, what is the input for this condition? What is the input test signal into this system? If KA equal to 500.
Parabola.
Yes, very good. Parabola input test signal. Okay, very good. So meaning we have a type and we have the input signal. Okay, done. How about value of KP and KV? When,
Infinity.
okay, just now you say is n equal to 0. Okay, for n equal to 0, this is the input is a parabola. Okay, how about the value KP and KV? Infinity? Okay, let's say we see back from our table. Okay, type 2. Okay, KP and KV is infinity. Okay, this is the information from this one. KP and KV is infinity. So, of course, error is a 0. Okay, the last one. Number D. What's the error of the system? ESS meaning is a steady state error. Okay, what's the error for this system?
1/500.
Okay, good. ESS equal to 1 over KA, meaning 1 over 500. This is the error, okay, for error of the system. Okay, that's the way macam mana you nak baca, how you want to read that summary table, and meanings that table as your benchmark. Okay, as your benchmark. Once you complete your calculation, you can refer back to that table to verify back, is it your calculation is correct or not. Okay, this is okay. Okay, siapa ingat how many types to define the steady state error? Okay, madam nak tanya. Ada berapa cara untuk kita define steady state error ni? Okay, tak apa. Before you come with the solution or before you share the answer, we finish this one first. Okay. This slide, page 20. Okay, this condition is a non-unity feedback. Okay, to calculate the error, you have to represent your system into unity feedback. Okay, you have to bear in mind to calculate the error, you have to represent your system into unity feedback. Okay, and then this is your forward gain. Okay, and this is your output. And this is your input. Okay, you have to represent your system in unity feedback. H equal to 1. Okay. Buruk pula ni. Okay, H sama dengan 1. Okay. If the system is a non-unity, meaning your H here is not equal to 1. Okay. When the unity or when the feedback is not equal to 1, okay, so you have to convert the non-unity feedback into unity feedback. Okay, let's say Madam label this is a figure 1 and this is figure number 2 and this is a figure number 4 and then this is a figure number 3 and figure number 4. Okay, so we have to convert our system figure A into system figure number 4. Okay, figure number 4, you can see the feedback equal to 1, unity feedback. How to convert figure 1 into figure 4? Okay, so you have to do the modification at figure number 1. You have to add on this one and this one. Okay, we have to add -1 and just now Madam Shay. Okay, you have to add on -1 and you have to add on this one. Okay, when we simplify back this one, you can get, you see what's the sign here? -1. Okay, this is a parallel, right? Here and here is a parallel condition or parallel connection. Okay. When we calculate back -1 here, -1 here. Okay, -1, -1, and then this is a plus -1. Okay, this is a parallel, right? Okay. So jadi apa? Minus apa? Minus you can get 1 plus -1 you can get 0. So 0 meaning we can back to this figure. Okay? You can back the original figure as a figure number 1. Okay? So that's why this is we have to add on. Okay, you have to add on in or you have to do the modification from the figure number 1. Okay, to show how we want to convert non-unity into unity feedback. Okay, so from there apa nak jadi, apa nak buat ni? Okay, Madam padam ni ya. Okay, so okay, so ni figure number 2. Okay, now kita dah tambah apa tadi? We add this one and we add this one. Okay. So, kita tengok. Now, let's see figure number 3. Okay, figure number 3 is we combine this one. Okay, we simplify this one, meaning this is a parallel. Okay, this is a parallel. Okay, you parallel H and -1. So, we will get this block. Okay, we parallel H and -1, we can get the blue blocks here. Okay, we can get this one. Okay, and then how figure 4 looks like. Okay, figure 4, how to get the figure 4? Figure 4 is kita buat apa kat sini ni? Kita feedback kan dia. Okay, we feedback, we apply the feedback connection rules and then kita akan dapat ni. We can get this one. Hasil or the result from the feedback. Okay, once we feedback in the green box, we can get this one. Okay, this one, Madam label with the G prime. Okay, this is our G prime. Because I want to show difference between this G and this G prime. G prime is after we convert non-unity, okay. G prime is after we convert non-unity into unity feedback. Okay. So meanings from here we already get our new block. We already get our new block. Kita convertkan non-unity into unity, so we can get the new one. This is your output. Okay, we get here G prime. Okay, we get G prime here, our new forward gain. This is our old forward gain in condition what? In non-unity feedback. And then now we go through step by step until you can get this G prime. Okay, so what's the formula for G prime? What's the formula for G prime? Okay, from the calculation, okay, you can get G prime equal to, oh my god, G prime equal to, inside the box, G, this is your forward gain, the old forward gain, 1 plus GS HS and minus G. Okay? Yes. Okay, this is a formula how to get the G prime. Okay, from the G prime, you can calculate. First, you have to determine your system type, and then from the system type, you can calculate your appropriate error constant, and then once you get the error constant, you can calculate the error. Okay, that's the way. If the condition is a non-unity feedback, you have to convert into unity first, and then from there, you calculate. You determine or you evaluate the system type, and you evaluate your error constant, and you can calculate your steady state error. Okay. Ada soalan tak? Any question? Is it clear how to convert non-unity into unity feedback? So far so good?
Yes, madam.
Okay, very good. Okay. This is exercise 7 is exercise for non-unity. Hopefully everybody try. Okay, hopefully everybody try. This is madam give one example, meaning H, non-unity feedback system. So actually guys, if you can memory the H equation, if you guys can memory this formula, G prime formula, you no need to prove step 1 until step 4. Okay, you no need to no need to show from your solution, from meaning you tak perlu apa, you no need to show back from step 1, you show step 2, 3 and 4. Okay, you no need to show all this process, but you have to remember the formula G prime. Okay, you have to remember this formula. Okay, what's the formula for G prime? G over 1 plus G multiply H minus G. Okay, that's the formula G prime. Okay, so meaning for exercise 7, you have to define your G prime here. What is your G prime? You have to write down what is your G prime. Okay. Okay, let's say this one is our system is a non-unity feedback. Okay. Non-unity feedback means you have to define the unity feedback, right? Okay, this is our output and this is our input and then this is our G prime. Okay, equal to just now, what's the formula? G S 1 plus G S H S and minus G S. Okay, so we already convert into unity feedback. Okay, so from here, you determine your system types, whether 0, 1 or 2. Okay, from next you have to calculate whether your KA, KV or KP. Okay, from here you determine your error. Okay, so the last one you determine what's the error, contribute from where, from KA, KP or KV. Okay, that's overview how to solve exercise 7. Any question? Ada soalan tak? Madam nak dengar. Okay, everybody clear?
Yes,
Clear.
yes, madam.
Okay, okay, very good. Din, boleh follow tak? Mana balung?
Okey,
Balung ada ke
boleh.
tak ada ni?
Ada.
Okay, very good.
Boleh.
Okay, so after this, Madam nak you all try. After we finish our ODL, I need everybody try this all exercise in this slide. Okay, now Madam nak come back to another ada extra notes tu. Okay, sekejap This one. Okay, this is apa yang Madam nak tunjukkan. Oh, saya tak potong kat belakang. Kejap Kejap ya. Nama tampal pula kat sini. Okay, extra notes. Okay. Still recording. Nampak tak slide baru ni? Takut this is salah lagi. Nampak tak slide baru?
Nampak.
This is another. Okay, this is actually Madam nak tunjuk. To calculate the error, kita boleh represent sistem kita unity feedback. Tapi kita boleh kira our steady state error in the two condition in two term. Whether we want to calculate into GS term. Okay, just now is in GS term. Okay, and then this is Madam nak tunjuk sikit aja, very simple how to calculate the error in term of TS. Okay, in term of TS. This is the block diagram slide. Okay. Okay, this is a block diagram slide. Okay, just now I share how to calculate the steady state error in term of GS. Okay, if the question give you like this block diagram, okay, you have to calculate the error in term of GS. Alright. If the question give you in term of this plot diagram, you have to calculate the error in term of this one, in term of TS. Okay, ni ada dua condition tau, and then jangan confuse. Okay, we have two type of closed loop system error. Okay, you can see from this figure. Okay, closed loop control system error. A is a general representation. B, we represent our block diagram for unity feedback system. Okay. And then the error equation or equation for E also different for both term, whether T or GS. Okay. So for T, let's say madam just scan through and a bit and very fast. Okay. What's the steady state error in terms of TS? Okay. This is I want to show or I want to prove how we get equation for E. Macam mana kita nak kira E tu? How we calculate equation for error from this block diagram. Okay, error is here. How to calculate the error? Error is input minus output. You can get equation number 1. Okay, what is a C? C is a T multiply dengan this is input, right? Okay, this is a signal. Sorry, this is a signal. Enter this block, we can get C. So we can get equation number 2. Okay, and then from equation number 2, you substitute into equation number 1. So kita dapatlah equation number 3. This is how we want to get the error from or using TS term. Okay, so bear in mind kita ada dua. Kita kira error based on T term or ataupun kita nak kira or we want to calculate error in GS terms. Okay, this is for TS in term of TS. Okay, this is the block diagram looks like. Okay, so let's say kalau you tengok okay, still using what final value theorem juga. Okay, we still use this one. We borrow final value theorem to calculate the error. Okay, we still use this equation. What's the error? What's the error just now? We substitute the error equation here. Okay. Oh my God. We substitute the error equation here. Okay. We use final value theorem. Okay. Error. This is our error just now, right? This is our error equation. Okay. So we substitute error into final value theorem. So we can get error T, meaning T is approaching to infinity. Okay. And limit S goes to infinity. We normally apply this one. S goes to 0. Okay. And then S multiply with E. So E is our error equation we discussed before. Okay, we substitute. So we can get error equation. Okay, in final value theorem. Okay, let's say example 7.1. Okay, from example 7.1, how to calculate steady state error in terms of T. Okay, just now from this equation, they provide to you transfer function for T. Okay, what's the transfer function for T? Ts equal to 5 over s square plus 7s plus 10. Okay, this is a transfer function for that block. Okay, and then apa you kena buat? What's you going to calculate? You have to calculate, you should calculate your steady state error. So meaning your error or ESS, steady state error, equal to limit S goes to 0 as ES. Ni E So substitutekan dekat dalam ni. Okay, ES. So limit S goes to 0. This is your S. And what is your E? E tadi apa? What's the E?
RS.
E, okay, R 1 tolak TS Okay. So this one is a RS 1 tolak DS. Okay. So if you solve this E, okay, this is your E. Okay, you solve E, you can get this one. You can get like the solution is the equation 7.7. You can get E. Okay, so once you can get E, let's say from here, so what is a E? E, E, E. So E, meanings you have to define your E. Your ES equal to R1 plus T. R adalah 1 over S. Okay, ni 1 plus 5 S squared plus 7S plus 10. Okay, so simplifykan dulu ni. So jadi you akan dapat, let's say contoh dia, yang macam saya yang kat atas ni lah, this one, this is your E. Allahu Akbar. This is your E. Okay, you akan dapat E dekat sini. Right, this is your E. Okay, and E, from there, we substitute E into the error equation. Okay, so let's say, sekejap madam buang ni sekejap. Nanti confuse pula ni. So saya buang ni. Okay, so from here, error equal to limit S goes to 0, S, and masukkan error dekat dalam ni, equation error, S square plus 7S plus 5 over apa? S goes to 2 plus 7S plus 10. Okay, this S and this S we cancel out. Okay, so dia akan jadi apa? S goes to 0. So meaning ni jadi kosong, ni jadi kosong, ni jadi kosong, ni jadi kosong kan? So you akan dapat this one is a 5 over 10. So meaning 1 over 2. So this is the error. Okay? Any question? Ada soalan tak?
No.
No.
Okay, very good. Okay, that's the example how to calculate the statistic error in terms of TS. Okay? So in terms of TS, dia straightforward. Dia senang saja. Yang in terms of G tu yang banyak sikit lah dia punya kerenah ni kan. Okay, so yang ini statistic error in terms of G yang macam as looks like yang whatever yang madam already discuss later. Okay. Okay, from this slide, okay, this is the yang madam mention tadi lah. Okay, they give you input, you substitute into the final value theorem, so you akan dapat this one. Okay, ni yang dia panggilkan KP. Okay, if the input R kan, KP you akan dapat constant, betul tak? You can get constant number. This is this slide they want to show how to get KP value. Okay, well, how to get the KP value? Okay, from here, meanings is as S equal to 1 plus KP. Okay, this is KP, right? 1 plus KP. Okay, and same goes to the previous. The next slide is when the input is a RAM. Okay, when the input equal to RAM, or when the input we give RAM, or we give RAM input to the system. So you can get when they here and here, you can simplify the equation until you can get the last one. The last one, this one, equal to 1 over, for input RAM is what? KV, 1 over KV. Okay? And then this is a 1 over KV. So how this equation to show you where what's equation to calculate the KV. KV meaning it's a velocity constant. Okay? How to get KV? KV equal to limit, limit S GS. Okay? This is where KV equation come from. Okay? From this slide or from this note, I want to show you I want to show you apa ya? I want to show you how the equation for Kp, Kv, and Ka derived, okay, from the final value theorem equation with three type of input, step, ramp, and parabola. Okay, guys. Okay, and then this one. Okay, example 7.2. Siapa dah cuba? This is, we analyze statistic error in term of G. Okay, so macam mana nak buat? So now your system already in unity feedback. Okay, just now they say find the statistic error for input 5 UT, 5 TUT, and 5 T square UT. And then they give the forward gain 120 times S plus 2 over S plus 3, S plus 4. Okay. Siapa dah cuba example 7.2? Siapa dah cuba this example or this exercise?
Belum.
Tak try lagi?
Belum.
Kenapa? Jumaat kan kita tak ada kelas. Kenapa tak cuba? Itu kan medium bagi nota lambat
Dia bagi lambat.
Betul terus tak tengok. Isnin cuti. Kenapa tak tengok?
Saya siapkan English. English kena hantar kerja.
Alasan. Okay, so cubalah sekarang. Macam mana nak buat? Cuba. Let's try now. Okay, everybody. Madam nak you all cuba. Dia nak buat final nanti ni. So, let's try this one. Example 7.2. Cepat. Let's try this example. Apa sistem type dia? What the system type for this example?
0.
Yeah, very good. Type 0. So meaning we see from the forward gain, from the denominator of the forward gain, right? So here, dekat sini, S N. So meaning Sn, if n equal to 0, meaning dapat 1 kan? Okay, let's say dekat depan ni 1 lah ni. Ni 1 lah kan? Okay, so n equal to 0. Okay, very good. Okay, so disuruh cari apa ni? Find the statistic error for input 5. 5 is a magnitude. Okay, normally a step is a UT kan? Kalau RAM is a TUT. Betul tak? Ini is a general equation ni lah. And then for the parabola is half T square UT. This is a general equation. For step, for RAM, and for what? For parabola. Okay, just now they give you 5. 5 is the magnitude for the input. Okay, for the input, right? Okay, for type 0, okay, for type 0, what's the appropriate error constant? KP, KA, KV.
KP.
KP. Okay, very good. You can get KP. So for KP, which one input yang you boleh dapatkan constant tu? From step, from ramp or from parabola?
Step.
Okay, very good. From step. Okay, so now we already know this is a type 0. Okay, minum buang From type 0. Okay, meaning ini yang kita akan guna as the input. Okay, so now we have to know our n equal to 0. Meaning this is a type 0. For type 0, the appropriate static error constant is a KP. So KV and KA ni you tak perlu kira pun tak apa. Okay, because this is whether you can get 0 or infinity kan. Okay, so how to calculate the KP? Macam mana nak kira KP? KP, what's the equation for KP? Limit S goes to 0, GS kan? Betul tak? Betul?
Betul.
Okay, so kita substitutekan equation dekat dalam equation ni. What's your G? Is 120, S plus 2, and this is S plus 3, and S plus 4. Okay, ni semua jadi kosong kan? This one 0, and this is 0. So meaning you can get 240 bahagi dengan 12 kan? Betul? Betul tak Din? 140 bagi 12 Itu adalah your KP. Betul ke?
Ya.
Betul?
12.
Okay. Okay, good. Okay. Now once you get KP, kena kira lah dia punya error. ESS kan? So what's the formula ESS? ESS sama dengan formula dia apa? 1 plus KP kan?
Yes.
Okay, but you have to remember apa dia punya magnitude input tadi. 5. Jangan lupa 5 ni. So you have to put in your calculation error magnitude 5 tu. So how to calculate kalau magnitude dia bagi 5? So how to calculate? This is the way. This one 5 letak kat depan. So masukkan ni dekat dalam kurungan KP. Okay. So equal to 5. Apa tadi? 1 plus 240 over 12. So that's the way how to calculate error when they give magnitude not equal to 1. Okay. Ada soalan tak? So kiralah ni. Dapat berapa? Okay. Senang je kan?
Nak
You.
tanya sikit. Yang KP, nak cari KP, dia punya formula limit GS saja, bukan GSHS.
H tu 1, tak payahlah kira.
Oh, okey, tak.
Okay.
Okey.
Tu saja. That's the way. That's how to calculate the error. If you already know the system type, so we directly calculate the appropriate error constant. Meaning now you will be given type 0. Okay, type 0, the appropriate constant only KP. Tak salah you all nak kira KV or KA. Boleh kira KV and KA. You can calculate KV and KA, but you can get unconstant number. Whether you can get 0 or you can get infinity. Okay, let's try 5 TUT. Example. Okay, let's try 5 TUT. We try this one. Let's say we try this one. We don't know. We don't know for type 0. Which constant? KA, KP, KV? We don't know. If you don't know which one contribute the constant number, you have to try for all types. You have to calculate your KP, you have to calculate your KV, and you have to calculate your KA. Okay? So let's say we don't know the constant contribute from which static constant Kp, Kv or Ka. So just now we already try for 5 UT. Now we try for 5 TUT. Okay, let's say for 5 TUT meanings Kv or Ka. Nak kira apa kalau kita nak kira RAM? RAM Ka ke Kp? Sorry, Ka ke Kv? Kv kan? Betul? Betul ke?
Betul.
Kv, apa formula dia? Kv, S goes to 0. Sekejap nah. S goes to 0. S multiply dengan GS kan? Okay, betul tak? So, we rewrite back our equation. S multiply with the 120. S plus 2. Ni darab nah. S times 3, plus 3, S plus 4. So dapat apa kat sini? Dapat apa ni? Ni dah jadi kosong kan? 0 multiply with the rest you can get apa? 0 kan? Okay, good. 0, you can get 0. Okay, you can get Kv 0. Okay, you can get Kp 0. What's the error? Apa error dia, Syah? Error sama dengan apa magnitude dia tadi? 5, 1 over Kv, right? Equal to 5, 1 over 0. Mak over 0 infinity kan? 5 darab infinity. Sama dengan apa? Infinity. Okay. That's the way kalau kita kira untuk semua constant. Okay. Let's say we try another one. Apa another one? Apa lagi satu? Parabola kan? Okay, parabola 5t square ut. So let's say kita kira lagi satu tu. Mana media nak gerakkan benda ni? Okay, let's say kita nak kira untuk parabola input. Okay, parabola input apa? Ka equal to limit s goes to 0 apa dia? S square kan? S
Yes.
square gs.
Yes.
So ni sama dengan limit s goes to 0 s squared multiply dengan term function tadi tu 120 s plus 2 s plus 3 s plus 4. Okay, now you can get, this is 0 kan? Ni 0.
Yes.
So ni 0, 0, 0. So meaning you can get Ka equal to 0. Betul? Betul ke?
Betul.
Betul kan?
Betul.
Betul.
Okay, so jadi apa dia punya error? Error equal to 1 over Ka. Tapi you have to bear in mind magnitude dia tadi 5. Okay, so kalau 5 tu apa magnitude dia yang sebenar? You remember tak kalau RAM, apa equation untuk RAM? Parabola. Okay, parabola equation dia sama dengan half t square ut kan? Betul tak? Betul tak?
Ya.
Betul.
Okay.
Betul.
So, dalam soalan tu, in the question, they give you, so dekat sini parabola ni ada trik sikit Dekat dalam soalan, they give you 5 t square ut. Betul tak?
Betul.
Boleh tak terus pakai equation ni? 5t square ut. Boleh ke tak boleh? Kita punya general equation kita adalah ini. Sebenarnya, dia sama dengan apa magnitude dia tu? Siapa boleh nampak? Berapa sebenarnya magnitude?
5/2.
Apa dia?
5/2.
Salah. Apa sebenar dia? Dia bagi ni. Tapi general equation ini. Berapa sebenar magnitude?
$2.5 setengah.
Salah.
Sampai half daripada 5 kot.
Berapa?
2.5.
Bukan. Asal dia. Sebelum kita darab dengan half tu berapa untuk dapat 5?
10.
Yes, very good. Boleh dapat duit raya. Okay Lasha, Madam bagi duit raya RM10.
Yay!
Wah.
10 darab setengah kan? C
Yes.
square UT. Dapatlah 5. Macam ni. This is considered is a trick kalau kita buat, kalau dia bagi parabola input tau. Selalu student tak boleh buat yang ni. So you have to bear in mind ini adalah dia punya general equation. Okay, dia bagi 5. Sebenarnya yang asal dia adalah 10. Okay, so jadi how to calculate error? So 10 dekat sini, lepas tu masukkan 1 over KA. Okay, dapatlah jawapan error. Okay, so ingat ya, this is how to calculate error for parabola. Dia ada trick sikit kat sini. So just now our KA kosong kan? Okay, this is our KA. So kita substitute lah dekat dalam ni. 10, 1 over 0. So meaning sama dengan 10 darab infinity kan? So jawapan dia
Yeah.
infinity.
Infinity.
Okay, this is the way. Kalau kita tak tahu sangat, kita tahu tak kosong tapi tak tahu dia constant daripada mana. KA, KB, KAP ke kira semua. Tak salah pun. Okay? Kalau kita tak boleh ingat lah. Kalau boleh ingat tak payah buang masa kira kan. Itulah dia punya beauty of the statistic error. Cewa. Okay, ada soalan? Ada soalan tak? Aisyah jangan lupa share number nak transfer duit raya.
Malu tak?
Okay, siapa ada soalan?
Tak ada.
Sure. Tak ada soalan, madam boleh bagi kuis lah macam ni. Okay, any question? Brian, Carlos, any question? Mark Joshua.
None.
So far so good?
So far so good.
Wow, very good. Carlos, are you there? Carlos, are you with me? Where Carlos? Senyap je ni. So, apa lagi? Let's finish our chapter time domain. We already discussed transient response and now we are already covered on steady state error. Okay, we have another 2 chapter to complete our syllabus. Okay, ada soalan tak? Aina? Okay, Aina ada soalan?
Tak ada.
Madam nak tanya satu je.
Ya Din?
Kalau jenis type GS ni, kalau kita tengok gambar rajah dia, nak tahu di type GS memang dia punya gambar rajah dia ada satu tu je. Macam contoh 7 tadi.
Mana?
Ataupun
Untuk
yang
untuk
tadi
slide.
yang example.
Ni ke?
GS.
Ni ke?
Yang macam ni je.
Okay, let's say dia depends. Kadang dalam soalan dia mention apa tau? Forward gain sama dengan apa-apa with unity. Dia akan mention dalam soalan with unity feedback. Kalau unity feedback maksudnya ni lah. Macam ni lah block diagram dia. Okay. Maksudnya untuk kira error, kita kena represent sistem kita in unity feedback. Okay. Kalau soalan tu dia beri dalam non-unity, kan, let's say lah dia bagi dekat bawah ni ada lagi satu. So dia buat H, S, katakan dia bagi apa? 10, S plus 1. Okay, kalau macam ni, then kena convert kepada yang G prime tadi tu. Ingat tak yang madam ajar tadi?
G prime, ya.
Formula. Yes. You kena apply formula G prime tu. Baru boleh kira error. Faham tak? Okay. Clear tak kat situ? Okay. So, the rest? Aina, any question?
Not yet, madam.
Okay. Carlos, maybe network is not okay. Faika, is it okay?
Okay, madam.
Okay, good. Hidayah, madam nak dengar seorang-seorang ni suara. Hidayah, is it okay?
Okay.
Okay, ma'am.
Okay, Carlos here. Carlos, is it okay for you?
Yes.
Okay. If you have a problem, please go through back our recorded video, right?
Thank you.
Sekejap, madam nak stop recording dulu.